Thank you, David. Good morning. Good morning, everybody here in the Keck building and the Keck Center. In this small room, we have one small overflow room as well, but we have a very large audience on the internet. We heard that there's something like 400 registered participants remotely for this event. So this is a workshop on the health risks of indoor exposure to particulate matter. I'd like to begin with a few introductions and then say a few words about the scope of and the organization of this workshop. First, the organizing committee, in addition to myself, included Richard Corsi, Tina Raponen, Howard Kippen, and Terry Brennan, and they will each be chairing sessions of the workshop, so they'll have a chance to introduce themselves more thoroughly at that time. Also, before we go on, I'd like to express thanks of the committee, on behalf of the committee, to the NAS IOM staff, David Butler, who, along with Guru Madhavan, organized an enormous amount of our operations behind the scene, and Anna Martin, who also assisted quite ably in getting the logistics running. It's really a pleasure to serve when you've got such incredibly strong support. And so thank you, David, Guru, and Anna. Also with us here today is Joe Alper, who is assigned as the rapporteur for this. He's responsible for producing a report out of this mess that will summarize everything covered in the next day and a half in language that's understandable to everyone. So I'm looking forward to seeing your report, Joe. And then, of course, we have a quite distinguished panel of speakers who I will leave the introductions of to the session moderators as we go on. We've organized this workshop into 6 sessions of 90 minutes each over the next day and a half. The sessions feature 3 speakers in each case, and the presentation time is 20 minutes, so we've allotted about a half hour in each session for discussion. That discussion would take place at the end. For people who are here or in the adjacent room, especially important because of the large web audience, it's essential that you use a microphone. So those of you who are sitting around the table have desk mics that you need to switch on if you're going to talk. And then we have portable microphones that are available for people who aren't sitting in front of a mic. And if you're in the overflow room, you can come into the primary room to access one of those microphones. If you're, excuse me, part of our web audience, you can email questions. The email address is indoor-pm@nas.edu. Again, that's indoor-pm@nas.edu. The incoming questions will be initially screened and moderated by David Butler, and then to the extent that we're able to, we will pass those along for allowing you to participate in the conversation. The speakers have been instructed to challenge us, to be forward-looking, and to be mindful that our audience is broadly multidisciplinary. And knowing a large proportion of our speakers, I'm sure they will discharge their responsibilities brilliantly. Regarding the scope of this workshop, I want to make 3 primary points. First, if air pollutants were animals in the zoo, particulate matter would be much more than just a species. It would be at least a whole class, if not a phylum or something even larger. Maybe like mammals. But even mammals aren't richly complex enough to capture the full diversity of particulate matter. In regulation for ambient air, particulate matter is designated with crude aggregation, PM2.5, the mass concentration of particles 2.5 micrometers and smaller, or PM10. But in reality, it is richly complex outdoors and indoors. And that complexity is both scientifically challenging and probably important for its health consequences. Among the features that vary and that matter greatly are the size of particles. So here, think about the smallest mammal and the largest mammal, and I'm going to blow you away with how much range there is in the particle size. The smallest particle might be 10 nanometers, even smaller in diameter. The largest ones we're concerned about are certainly at least 10 micrometers, if not larger. 3 orders of magnitude in diameter is 9 orders of magnitude in mass. That's like, if we use a different analogy, the difference in the net wealth of somebody like Bill Gates and somebody who, well, let's not even say somebody, the money that's in my wallet. That's not very much, by the way. The chemical composition also varies over a vast range. It's complex and it's not easily summarized as we can with particle size. Because of the complexity, it's a challenge to study in full detail particulate matter. And one of the organizing principles we use to simplify the story is source-oriented. So I'll come back to source-oriented perspective in a minute, but it's also the subject of our first session. So the first point, again, in summary, is that particulate matter is a richly complex category of air pollution. Second, almost everything we know about ambient particulate matter, PM 2.5, and its health effects, which constitutes the reason for regulating it, actually reflects our understanding of indoor exposures, almost everything. How can I make that claim? Well, it combines two pretty simple facts. First, we spend 90% of our time indoors. And second, the indoor environment protects us from particles of outdoor air to varying degrees, but a central tendency estimate would be about 50%. So whatever the particulate matter is in outdoor air, you're getting about half of that outdoor particulate matter present in the indoor air. And if we're spending 90% of our time indoors, then you can do the math, about 80% of the exposure is indoor exposure. And when we run an epidemiologic study that compares outdoor measurements of particulate matter with health risk statistics, we find, or health outcome statistics, we find consequences, but those consequences reflect exposures that primarily happened indoors, even when the particles were of outdoor origin. Why does this matter? Well, I can think of 3 reasons. There are probably many more. First, outdoor particulate matter is transformed when it comes indoors. The size distribution and the chemical composition of the particles of outdoor origin that we are exposed to indoors is not the same as if we were being exposed outdoors. Second, the degree of protection varies. The degree of protection you get in one building can be quite different than the degree of protection in another, and to the extent that that is systematically variable, that has influence on how we should think about epidemiologic studies for outdoor particulate matter. And that gets me to the third point, which is the opportunity to intervene for public health protection in advance of solving the problem of outdoor particulate matter. We have a possibility to do better in protecting public health while we're working on the problem of improving outdoor air by reducing the indoor exposure to particles of outdoor origin. We know practically how to do that, and largely what we're missing is a matter of will to apply that knowledge. Third, the indoor exposures that occur that are of health risk significance are to much more than just the outdoor particulate matter that penetrates and persists and is transformed indoors. There are quite important indoor particle sources. I'll just give some examples now. We'll be exploring these and others throughout the course of the day and a half. These include combustion, candles, cooking on an open flame. In fact, cooking, whether it's gas-fired or electric, is an important source of particulate matter indoors. Heating, in fact, is an important source. Heated surfaces are an important source of indoor particulate matter, whether combustion is involved or cooking is involved. And we'll hear a little bit about that, I think, in the next days. Settled dust can be resuspended. That settled dust can carry with it toxic elements. It can also carry with it biological materials that can induce a physiologic response. Those biologic materials include mold spores, bacterial fragments, dust mite detritus, and many other entities or components. We expect these exposures to be important contributors to health risk, and we expect that those exposures would actually influence or modify the way we understand the health consequences of exposure to particles of outdoor origin. And there are things that can be done in buildings to modify those risks. So with that as a bit of an introduction, I want to make one more broad point, which is to just delimit the scope of our workshop. Our interest here is in circumstances that apply broadly, but apply to conditions in the United States and other similarly developed countries. So we're concerned with particles, as I've already alluded to, that would have originated in outdoor air. We're concerned with particulate matter from indoor sources. We're concerned with the full size range of particulate matter and the full chemical and biological composition, except we're not extending our investigation to include infectious disease transmission, which can be viewed as a particulate matter problem. So communicable diseases, although they have an overlap with the scope of this workshop, are outside the domain. And we're also not concerned, although it's an important global public health problem, with biomass cooking as it's practiced in mainly the rural parts of developing countries and leads to extraordinarily high particulate matter exposures. But that topic, worthy of its own, of study in its own right, is outside the scope of this workshop. So that's the introduction. Let's have a terrific workshop. Now let me introduce our first speaker from the US EPA, which has sponsored the organization and execution of this workshop, David Rowson.